Hello everyone and welcome back to our course on microcontrollers and microprocessors. I am Sahil and as I have mentioned earlier, I have completed my bachelor in technology in electronics and telecommunication engineering from Vishwakarma Institute of Technology from Pune, and currently I am pursuing my masters in computer engineering from Veer Mata Jijabai Technological Institute in Mumbai. In this course, we are building a strong foundation in understanding how processes work, starting from their basic concept and gradually moving forward to advanced architecture and programming. So far, we have completed Unit 1, where we understood the fundamentals of microprocessors and microcontrollers, their architecture and their applications as well. In the last lecture, we compared the microprocessors and the microcontrollers, which helped us understand where each of them is used in the real world systems. From today, we begin with Unit 2, that is the instruction set and programming of 8085. In this unit, that is extremely important because it introduces us to one of the most fundamental and widely used microprocessors for learning, the Intel 8085. Understanding the 8085 will help us build a strong base for learning assembly language, programming, and the processor architecture as well. In today's lecture, which is lecture 6 of this series, we will focus on Intel 8085 architecture. We will begin with introduction to 8085, then understand its 8-bit characteristics, its 40-pin configuration, memory addressing capabilities, power requirements, and finally its evolution from the earlier 8080 processor to the currently 8086 processor. Let us begin with the introduction to Intel 8085 microprocessor. The Intel 8085 is an 8-bit microprocessor developed by Intel in the mid-1970s. It is one of the most important processors in the history of computer architecture education because it provides a simple yet most powerful platform to understand how a microprocessor works. The 8085 was designed as an improvement over its predecessor, that is the Intel 8080, with enhancements in performance, ease of use, and system integrations. It is widely used in academic learning because of its architecture is simple enough to understand while still covering the essential concepts of microprocessor operations. The 8085 microprocessor performs operations such as arithmetic calculations, logical operations, data transfer, control operations. It reads the instructions from memory, processes data, and produces the output just like any other microprocessor, but in much simpler and more understandable way. Now, let us understand what it means when we say that the 8085 is a 8-bit microprocessor. An 8-bit microprocessor means that the processor can process about 8 bits of data at a particular time. This means that the size of the data that the processor can handle in a single operation is 8 bits or 1 byte. The internal registers, arithmetic logic units, and the data bus of 8085 are all designed to handle the 8 bits data. This determines how the data is stored, processed, and transferred within the system. Because it is 8085 is an 8-bit microprocessor, the 8085 is suitable for its basic computational tasks and simple control applications. While modern processors are 32-bit or 64-bit, the 8085 still provides a clear understanding of fundamental concepts without the complexity of advanced architectures. Next, let us discuss the physical characteristics or the structure of 8085, which is its 40-pin configuration. The Intel 8085 is packaged in a 40-pin integrated circuit. Each pin on the microcontroller has specific functions. These pins are used to connect the processors to memory, input-output devices, and the power supplies. The pins of 8085 can be broadly classified into different categories. Some of these pins are used for address bus, some of them are used for data bus, while some of the control pins or signals and some for the power supply and clock signals. The address and the data lines are particularly important because they allow the processor to communicate with the memory and the external devices. Control pins are used to manage operations such as reading from the memory, writing to the memory, and handling the interrupts as well. Understanding the pin configuration is most important because it helps in designing hardware systems that use the microprocessor. Now, let us move to the one of the most important features of 8085, which is the address bus and the memory access capabilities. The Intel 8085 has 16-bit address bus. This means it can generate 16 bits of data, allowing it to access 2 to the power 16 memory locations, which is equal to 65,536 locations or 64 kilobytes of data. Each memory location stores 8 bits of data, so the total addressable memory space is 64 KB. Addressing capability determines how much memory the processor can directly access. For 8085, 64 KB of memory was sufficient for many applications during its time, especially in embedded systems and educational setups. The address bus is unidirectional, meaning it carries the address from the processor to memory or input-output devices. The processor places the address on the address bus to specify where the data should be read from or written to. In addition to the address bus, 8085 also has 8-bit data bus, which is used to transfer the data between the processor and the memory. Now, let us discuss the power supply requirements of 8085 microprocessor. The Intel 8085 operates on a single plus 5 volt DC supply. This was an improvement over the previous processors like 8080, which required multiple power supply voltages. Because 8085 requires only a single power supply, it simplifies the system design and reduces the hardware complexity. This makes it easier to build the microprocessor based systems using 8085. In addition to power supply, the 8085 also includes an internal clock generator, which means it does not require an external clock circuit in many cases. This further simplifies the hardware design as well. Now, let us discuss the evolution of 8085 from the Intel 8080. The Intel 8085 was developed as an improved version of 8080, which was one of the earlier microprocessors. While the 8080 was powerful for its time, it had certain limitations that made the system design more complex. One of the major improvements in 8085 was the simplification of power supply requirements. The 8080 required multiple voltage levels, whereas the 8085 operates on a single plus 5 volt supply. Another important improvement was the inclusion of internal clock generator, which eliminated the need for additional external clock circuitry. The 8085 also introduced improved interrupt handling mechanisms, making it more efficient for its real-time applications. Additionally, the instruction set of 8085 was enhanced and processor became much more easier to interface with memory and the input-output devices. Because of these improvements, the 8085 became more reliable, easier to use, and more suitable for educational and embedded system applications. Overall, the 8085 represents a significant step forward in the evolution of microprocessors. It combines the simplicity and essential functionality, making it an ideal processor for learning and experimentation. As we continue this unit, we will explore the 8085 in much more detail, where we will study its registers, its flags and the instruction set, the addressing modes and the assembly language programming as well. These concepts will help you understand how the programs are written and executed at the hardware level. Now this brings us to the end of lecture 6, that is the Intel 8085 architecture. Today we introduced the 8085 microprocessor, understood its 8-bit nature, explored the 40-pin architecture configuration, discussed memory addressing capability of 64 KBs, examined its power supply requirements and understood how it evolved from the earlier 8080 microprocessor. In the tomorrow's lecture, we will go deeper into the registers and flags of 8085 microprocessor. We will study the register sets, accumulator, program counter, the stack pointers and flags and understand how they are used during the instructions execution. If you are enjoying this course and want to build a strong understanding of microprocessors architecture and programming, make sure to subscribe to my channel and stay tuned for the upcoming lectures in this series. Until then, thank you for watching and see you in the next lecture. Subscribe to my channel and follow me for more such updates on engineering and science related videos. Have a great day.